In this third and final video on set operators, I'll be covering how you use except. And after that, I'll show you a technique that you'll be able to use to be able to filter or aggregate the results after you've used a set operator. So far, we've only been using order by on any results we get after using a set operator. If you tried to use where, group by, or having, you may have noticed that that won't work. So I'll show you a technique to get around that. Let's start with except though. Except implements the set difference. So that is, if we call our two input queries A and B, then except will return all the rows that are in A that are not in B. You can kind of think of it as A minus B. And as a result, the order of the queries matter, unlike using union or intersect. And of course, as with all the set operators, by default, except will only return the distinct rows, while except all will return duplicates. Okay, let's have a look at an example. Let's write a query to list all the films that have never been rented out. We've written queries like this before using left joins. Let's see how we can do it instead using except. So first, we'll just start with selecting all the film IDs from the film table. And from this complete list of films, we now want to remove the films that have been rented out before. So we can put parentheses around this query. We'll indent it, and now we'll use except. And what we want to do is return the film IDs from the rental table. Of course, the rental table itself doesn't hold film IDs, it holds inventory IDs, so we need to join on to the inventory table to get the film IDs. Let's add a semicolon at the end, and let's run this query. We obtain 42 rows, 42 films that have never been rented out. Those films were in our film table, and then from that film table, we remove any of the films that were rented out. Pretty simple, right? Using except all is a little bit trickier. And as I did with intersect all, which also was tricky in its own way, I'll use some predefined tables from value lists to show how it works. So I'll paste in here a query that we're going to be working with. In this query, the first table contains the values 1, 2, and 3 in a single column called n, and the second table contains the values 1, 7, and 8. If I now just swap this to using except only, you should be able to look at this query and figure out what it's going to output. The first table contains the values 1, 2, and 3, the second table contains the values 1, 7, and 8, so our output should just be 2 and 3. If I use except all, that's actually going to print exactly the same thing, just 2 and 3, but look what happens now if I change one of the values from the first table from 2 to 1. So the first table now contains 1, 1, and 3. Let's run this. So that's interesting, we got 1 and 3, so even though 1 appears in the second table, we still get 1 in our output. What's happened here is that except all performs something closer to a minus operation. It does a one-to-one match for each of the values in the first table to each of the values in the second table. If it finds a match, that row gets eliminated from the output. But it won't necessarily remove duplicates, because there's 2 1s in the first table and only 1 1 in the second table. 2 minus 1 is 1. If that's a little bit unclear, let me show you what happens now if I change this 3 to a 1 as well, and I run this. I now get 2 1s in the output. You can think of it as being this one got paired with this one, and that got eliminated, that got removed, but these 2 1s didn't get paired with any values in the second table, and so they remain in our output. So except all can have duplicates in the output. If I change this to 6, you'll see 6 in the output now as well. If I change these all to 6, so now I've got 3 6s, you'll get 3 6s in the output, because there's no 6 down here to offset that. If I introduce a single 6 here, now I'll get 2 in the output, 1 more 6 here, now I get 1, and if I add 6 here, now I'll get 0. So I hope that's clear how that works, and how it's different from just using except. A final topic I wanted to touch on was you may have noticed that you can only use order by and limit to the result of a set operator. Let me change some of these values back. I'll make this 1, 3, and 2. And I can leave these down here as 666, that's fine. If we run this query, I get 1, 2, and 3, and I can use order by here. So I could write order by n, and I'll put descending, and that works just fine. And I can also limit the results too. So if I wanted to only output the largest value, I could just say limit 1, and that works fine. So order by and limit can be used to the result of a set operator. Watch what happens though if I try to use a where clause. It doesn't work, I get an error. Similarly, I wouldn't be able to use a group by clause. I'd also get an error there. How can you get around this? What if you did actually want to filter or group by the results of a set operator? Well, this is where something that we learned earlier in the course can come in handy. Table subqueries to the rescue. We can simply turn this entire query into a table subquery. So let's start up the top, let's say select n, and we'll say from, and now we'll just wrap this entire expression into its own table, and we'll indent it for clarity, and we'll alias that table as t with a single column called n. Now that we've done that, we can use where, group by, or any of our other clauses that we like. We just had to wrap that as its own table subquery. That concludes our brief look into the different set operators. We looked at union, intersect, and except, and we saw some examples of how each can be useful, particularly when it comes to simplifying some of the queries that we've done in the past, where we might have used joins or subqueries. Sometimes the set operators give us a really nice way to just express our solutions in a much clearer and more obvious way.